Hi everyone. We've learned how to multiply rational expressions, simplify rational expressions, and divide rational expressions. Today we're going to look at how to add and subtract rational expressions. And they work just like numbers. When we have common denominators, the rule is to keep the common denominator and add and subtract the numerators. So the answer here would be 15 minus 3 is 12 over 10c. And of course, we could simplify that by dividing through a 2. So we get a 6 and a 5 here. And the answer in simplest form would be 6 over 5c. And here is our answer. And it's understood that c is not equal to 0. All right, now let's take a look at the next one. In the next one, we have subtraction and we have a binomial common denominator. So we'll write the common binomial common denominator, but when we subtract the numerators, we have to be very careful because here, because the second numerator is a binomial, we should put parentheses around it. And this is true for subtraction. Addition as well, but it doesn't affect the answer when we distribute the 1. So we have x plus 6 here. And we simplify. So we get x squared plus 2x minus x minus 6 over x plus 3, which simplifies into x squared plus x minus 6 over 3. And of course, we always try to x plus 3, I should say. We should always try to simplify the fraction by factoring it. So this factors into an x plus 3 and an x minus 2. And remember, we can only divide through when all addition and subtraction are in the parentheses. So the answer to our problem is x minus 2, with the understanding that x is not equal to negative 3. Okay, and that's our simplest form. So to summarize, when we add and subtract with like denominators, we add or subtract the numerators and we keep the common denominator. And usually, we should simplify our answer. And remember, to simplify the answer, we have to factor and divide through. And remember, we can only divide through if all addition and subtraction are in the parentheses. Okay, let's try 2 on the next page. All right, so let's copy these 2 problems down in our notes and take a few minutes and try to combine them and simplify the answer. All right, so let's take a look at number 3. So in number 3, we could just combine the numerators, and we have addition here. We can put parentheses around that, but again, that we don't have to, we just distribute a 1, so it doesn't affect it. So we get 4x squared minus 5xy plus 2xy minus y squared over x squared minus y squared. We combine, we get 4x squared minus 3xy minus y squared, all divided by x squared minus y squared. This is factorable, and it factors into x minus y times 4x plus y, all divided by x minus y times x plus y. And we can certainly divide through the x minus y's. Oops, I erased them by mistake. Wait, let me just get them back there. So x minus y and x minus y. So what I really wanted to do is put red here and divide through. So our final answer is 4x plus y over x plus y. And again, it's understood that x is not equal to negative y, and x is not equal to y as well. Okay, now let's take a look at the second one. In the second one, we keep the common denominator, but we have to put parentheses around these numerators, especially if they're subtraction. And again, subtraction is the key here. So we get 4x plus 5. And here, because we're subtracting x minus 2, it becomes minus x plus 2. And that's a very common error. We combine like terms. We get 3x plus 7 over x plus 3. And this cannot be factored. We cannot divide through. And that's our final answer, with the understanding that x is not equal to negative 3. It's very fun to compare the graphs of this function to the graph of the difference of these two functions. They should overlap. And we'll try to do that at the end of the lesson today. All right, now let's look at the next page. So I wrote number 5 here. And what is different about these two fractions? Yes, they do not have a common denominator. And to find a common denominator, we use a little bit of prime factorization. So let's take it on the side. 21x can be factored into 7 times 3 times x. And 3x squared can be factored into 3 times x times x. So to get a common denominator, what we're missing is, well, we should get the least common denominator, or the least common multiple. And to get the least common multiple, we list all the different prime factors that appear, and that's 7, 3, and x. And we raise each one to the greatest exponent. So the greatest exponent for 7 is 1, the greatest exponent for 3 is 1, and the greatest exponent for x is 2. So the least common denominator would be 21x squared. So to get that least common denominator, we would take the first fraction and multiply it by x over x. We would take the second fraction and multiply it by 7 over 7. And these are the factors that are missing. So when we put them together, we get 2x over 21x squared plus 35 over 21x squared. And the final answer would be 2x plus 35 over 21x squared. Again, this is not factorable, so this is our answer in simplest form. So to find the least common denominator, okay, so let's write a little summary for that. Multiple or least common denominator. What we have to do is we have to prime factorize, so express all denominators as a product of prime factors. Then we list, okay, so write each different prime factor that appears and raise each to the greater exponent. And then, of course, find the product, which is your least common multiple. So let's take a look at another problem. Number 6. Let's take a look at something that's a little bit more complicated, like x squared over x plus 2xy plus y squared plus 2x minus 2y over x squared minus y squared. Now this one's a little harder because the denominators are trinomial and binomial. So let's just factor each one right away. So a good idea is to factor everything. Oh, this should be an x squared. Factor this. So this is x plus y times x plus y. And this one comes out to be, okay, I could factor out a 2 here, but I'm going to factor out the x minus y because watch what happens in this one. This is the difference of two squares. And what happens before I add them, we could actually simplify this by dividing through the x minus y's. So this becomes x squared over x plus y times x plus y plus 2 over x plus y. Now, these are already in prime factored form, and the prime factor that appears is x plus y, but the greatest exponent is squared. So this fraction has to be multiplied by another x plus y divided by x plus y so that we have a common denominator. So we have here x squared plus 2 times x plus y, all divided by x plus y times x plus y. So when we multiply this out, we get x squared plus 2x plus 2y over x plus y times x plus y. Unfortunately, the numerator cannot be factored as is. Even though we could still factor out a 2 and get an x plus y, we still cannot divide through because remember, the major operation has to be multiplication. All addition and subtraction have to be in parentheses. So this is our answer in simplest form. And we are done. And I'll write a little note. Since the numerator cannot be factored, we cannot simplify. Okay. All right. So let's summarize how to add and subtract fractions with different denominators. So to add or subtract rational expressions with different denominators, the first thing we have to do is completely factor all denominators. Okay, this is a very good first step. Now you can do this mentally, but we find the least common denominator or multiple of all the denominators. And here comes the key. We multiply each rational expression by a form of 1 as needed to form the least common denominator. Okay? And then, of course, we use the rules and then use the rule for, use the rule for adding or subtracting rational expressions with the same denominator, which is keep the denominator and add or subtract the numerator. And remember, keep that denominator in factored form because we might have to factor the numerator at the end and divide through. Okay, so let's try another one. All right, now let's take a look at this one, number 7. Notice that the denominators are almost alike. They're in the form of a minus b and a b minus a. Now, when they're together with one in a fraction, we discussed that this divides through to a -1, as long as a is not equal to b. Over here, though, because we want a common denominator, we have to multiply one of these fractions by -1 over -1. So let's do that in the second one. So we're going to multiply one of these fractions by, wrong color, by a -1 over -1. This is the form of 1. And I'll put this one in parentheses because we have to distribute. So we get 5x over x minus 2y minus, okay, now if we distribute this, we get 7 minus 3y over x minus 2y. But then when we combine, we have to be super careful because the second part has to be in parentheses in the numerator. So we get as an answer of 5x minus 7 plus 3y over x minus 2y. And that gives us an answer of it gives us an answer of 5, that's the answer, 5x plus 3y minus 7 over x minus 2y. And this is our answer in simplest form. So that I found a little tricky because of the -1 over -1, in addition to the fact that we already have subtraction. So be very, very careful. All right, so let's try a few more. All right, let's copy this problem and give yourself a few minutes to try this and simplify it as much as you can. Again, keep the denominator factored. All right, so let's begin. So if we start factoring this denominator, it becomes, well, 2 factors of 20 that add up to 9 would be 5 and 4. And here, 2 factors of 12 that add up to 7 would be 4 and 3, so we could factor that quickly. And notice that both of these share an x plus 4. This has an x plus 5, and this has an x plus 3. So a good shortcut to use is to multiply by the factor that is missing. So they all have the same 3 factors. So I'm going to rewrite this step with a little space. So notice that this one is missing the x plus 3. So I'm going to multiply the top and bottom by x plus 3 over x plus 3. And this one is missing the x plus 5. So I'll multiply the top and bottom by x plus 5 over x plus 5. So now let's make one big denominator that's factored, x plus 5 times x plus 4 times x plus 3. And we're going to combine the numerators. So we have x times x plus 3, do not multiply yet, minus 4 in parentheses x plus 5. Now let's distribute. So we get x squared plus 3x minus 4x minus 20, all divided by x plus 5 times x plus 4 times x plus 3. We combine like terms in the numerator. We get x squared minus x minus 20 over x plus 5 times x plus 4 times x plus 3. We can factor the numerator into two factors of negative 20 that add up to negative 1, or negative 5 and 4. And we see that we can divide through, but just an x plus 4. So our final answer, and leave it in factored form, is x minus 5, so let's erase this, times 1 over x plus 5 times x plus 3. And we cannot divide through any factors. They are not alike, so this is our answer in simplest form. Notice that in this particular problem, sometimes we can factor the numerator, sometimes we can't. And sometimes we can factor it, but there aren't any common factors to divide through. So oftentimes the answers look very complicated. Okay, let's try this last problem. Okay, so this is the last problem I will do with you. And notice now we're going to combine three fractions with different denominators. Also notice that these two denominators are, well, when we factor here, this denominator and this denominator, we'll see that they're almost alike. So you might have to refer to problem number 7 to help you do this problem. Okay, try it yourselves and then we'll go over it. Okay, let's begin. We're going to start factoring the denominators. So this gives us an x plus 2 times an x minus 2. This is, now because we have an x minus 2 down here, we can factor out a negative 1, but we'll save that. Let's save it. And this one is itself. Now, to make the denominators look more alike, we're going to take this fraction and multiply it by negative 1 over negative 1. So we'll just worry about the x minus 2. So it'll become an x minus 2. So we'll multiply this by a negative 1 over negative 1. And we'll put this in parentheses. 5 over 2 minus x. And I'll rewrite the rest. Okay, and 2 plus x and x plus 2 are the same because of the commutative property of addition. So now we have 2x over x plus 2 times x minus 2, and I'm going to leave a little space here if I have to, plus negative 5 over, and this becomes x minus 2, which is good, minus 1 over x plus 2. In fact, I'm going to move this over and erase this here. Okay, so we see that the least common multiple is x plus 2 times x minus 2. So this already has the least common denominator. So we'll multiply this fraction by an x plus 2 over an x plus 2. And we're going to multiply this fraction by an x minus 2 over an x minus 2. And these technically have to be in parentheses. So putting all the numerators together, and we'll do this all in one step. The common denominator is x plus 2 times x minus 2. So we get 2x plus negative 5 times x plus 2 minus 1 times x minus 2. Now let's combine the numerators. We get 2x minus 5x minus 10, if we distribute here, minus x plus 2. And the denominator is still factored. Notice I didn't touch the denominator. Now when we combine like terms here, we get negative 4x, because here we get a negative 3x minus x. So we get a negative 4x minus 8 over x plus 2 times x minus 2. This can be factored. We can factor out a negative 4 to get an x plus 2 over x, and then the same denominator, and divide through the x plus 2's. So the final answer is negative 4 over x minus 2. And that's our answer in simplest form. We didn't write the restrictions for the others, but the restrictions are understood to be x cannot equal 2 or negative 2. And it would be fun to look at the graphs of these. Let's see. Okay, so I wanted to show you how to check the problems that we've done. So the first problem that I picked, well, let me just turn this off. The first problem that I picked was problem number 4, and that was y equals 4x plus 5 over x plus 3 minus x minus 2 over x plus 3. When we sketch it, we get this. And notice that there's a vertical asymptote at x equals negative 3, which is what we expected. There's no value of x here that would make this fraction 0 over 0, so there's no open circle. And when we simplified it, we get the same graph. Notice that the red graphs and the blue graphs coincide, so they match. But the next problem, the last problem that we did, is very interesting. It was the problem where we added and subtracted 3 fractions. Now, when we graph this, we have 2 things. We have a vertical asymptote at x equals 2, which is right here, and that's when the denominator is 0. But in the first fraction here, both the numerator and denominators would equal 0 after we combine, when x is equal to negative 2. Now that's not apparent, but it becomes apparent when we start combining. So in this particular graph, there is a hole at x equals negative 2. And if I click it, if I get to negative 2 here, notice that at negative 2 it's undefined. But that's only because we get a 0 in the numerator and denominator, and we divide it through an x plus 2. Whereas when I graph its simplest form, I get this purple graph. Wait, does it appear purple? No, I don't know why it doesn't appear. It should appear. Let me do this. The purple graph coincides with the green graph, and notice that they do overlap. But in this purple graph, we do not have a hole at x equals negative 2, because as it is in its simplest form, it appears that x equals negative 2 is included. But if we look at the very first graph, the green graph and the purple graph, just turn this off. Look at the purple one. Notice that when I highlight x equals negative 2, it appears that it is defined. Let me see if I could get to it. Not quite. Here. At x equals negative 2, the answer is 1. Yes, it is 1 when I look at this fraction, but we should add the restriction that x cannot equal negative 2, because the original problem was this. And that was the graphical interpretation.